Hi, today we are talking about limiting reactants. A limiting reactant is defined as any reactant that is used up first in a chemical reaction. So basically, it's the reactant that runs out and stops the reaction from continuing forward after that. It's responsible for determining the amount of product that can be formed in a reaction, as a reaction can only continue so long as you have all of the reactants required. Um, if an insufficient quantity of any of the reactants um, I is introduced into the situation, it will limit the amount of product. So once one of the reactants runs out, that is all that we will get. No more product will be formed. Here's an example that I really like. Tacos. This is something we're all familiar with, and tacos are a food that consists of a number of different reactants all put together to form one product. So in this example, I'd like to suggest that we have excess meat, salsa, cheese, and lettuce. All right, so we have big bowls of all of these things, no concern for running out. But if we only have 2 taco shells, we're only going to make 2 tacos. In this case, the taco shells are the limiting reactant. Once those 2 shells are filled up and eaten, we can't make any more tacos even though we have meat, salsa, cheese, and lettuce left over. We don't have one of the important reactants to continue to make the product. This is the same way that I want you to think about chemical reactions. And I'm going to run through a few different suggestions or steps on how you can actually go through and calculate the limiting reactant in a chemical equation. So we want all of our reactants to be in moles. Okay, we're doing this so that we can compare them in the balanced chemical equation. If they are not in moles, we need to convert them to moles. So the first step is get all of your reactants in the value of moles. Choose one of the reactants, and you can pick either one. Typically, we'll do this with a system that has 2 different reactants, an equation with 2 different reactants. And we're going to solve, using stoichiometry, what an ideal amount of the second reactant is. So we'll take one of the reactants, whichever one we like, and we'll run through using molar ratios to figure out what would be an ideal amount of the second reactant to work with it. We will then compare the ideal value to the real value. So we will need to have to start out with 2 values to actually go through these calculations. So if the ideal value is less than the actual value, the component that we chose and started our calculations with is the limiting reactant. If the ideal value is greater than the actual value, the component that we ended with is the limiting reactant, so the one that we calculated the ideal value for. Let's take a look at a real example of this. If we have this balanced equation for the production of ammonia, and we are given 2 moles of N2 and 4 moles of H2, here we've already got these values in moles, so we don't need to do any extra conversion. We then can pick one of them, and I'm going to choose 2 moles of N2. We want to figure out what would be the ideal amount of H2 to react with 2 moles of N2. So times in a line, we're going to cancel out moles of N2, converting to moles of H2, and if we pull the coefficients from the balanced chemical equation, we see that the ratio is 3 to 1. So we're canceling out moles of N2, and we are now in moles of H2, which is what we want, so we put an equal sign, and see that the value is 6 moles of H2. Now, we compare our ideal value that we calculated, so 6 moles of H2, to the actual number of moles of H2 that are present in the system. In this case, 6 is greater than 4, so H2 is the limiting reactant. If we have 2 moles of N2 and 4 moles of H2, the 4 moles of H2 will run out first or be used up first according to the balanced chemical equation at the top of this slide. As always, check the comments section for more practice and pages in your textbook.